Hi, I'm Technomora and welcome to my channel. Today I present you the second and final episode in the repair and restoration of a Technics SL-PG480A CD player. So grab something to drink or maybe a favorite snack, sit back in your seat and enjoy. Now the weather has improved, is the ideal moment to give the case of the Technics CD Player a fresh layer of paint, and I'm going to use matte black paint, which more or less corresponds to the color which is used now on the cover of the Technics. So there you go. What I'm going to do is I'm going to use very fine grit sandpaper. So in fact I'm going to use 1000 grit sandpaper to sand out the little imperfections. I'm going to use wet sanding actually, and once that is done I'll give it a clean, and then I'll give it a primer layer and the final layer. After wet sanding it with 1000 grit sandpaper, I gave the cabinet top a cleaning with degreaser, and proof that the degreaser did its work is when you clean it off, all off with pure tap water. The tap water flows evenly over the surface. That means that the degreaser actually did its work. So now the top is completely clean. I'm going to wipe it dry and then let it dry on its own for maybe 20 minutes or so. Alright, the cover is dry and degreased, and you can see it has a slightly gray sheen because I treated it with sandpaper, but it's dry and clean now, so I can give it a first coating of primer, and I'm going to use dark gray primer on all sides of the cover. And once the primer is dry, we're going to give it a final layer of matte black coating. Alright, I'm back to investigating what could be wrong with the CD reader mechanism. I hooked up one of the leads which go to the spindle motor, which is located behind the spindle wheel, so this wheel here, and I hooked it up to my oscilloscope over there to see whether there's any sort of signal registering once I activate the CD reader, or I simulate activating it by opening and closing it. Right? Now, one of the first things I need to check is whether the laser diode, which is located right here, okay, I need to check whether the laser diode still functions. I mean, if it doesn't function, obviously it's not going to see, quote unquote, if there is a disc available or not. So let's say it's a quick win in the sense that I can spot if there are any obvious problems with the laser diode, right? Now, one of the advantages of my camera is that it is rather sensitive to infrared light, and the laser diode of a CD player emits in the infrared, which is perfect, of course. So I want to see if and when I close the CD player, yeah, whether the laser diode reacts or not. That is to say, whether it starts to glow in the infrared and whether it moves a little. According to the service manual, the laser head or the laser diode assembly should move up and down a little. But obviously, since the reader is standing on its side, it should move into and out of the image, right? So let's have a look if that happens. Okay, so watch the little laser diode lens. Okay, so I open the reader now. Okay, so now watch the laser diode as I close it. There you go. There is obviously an infrared signal. This means the laser diode assembly is more than likely working. So now let's concentrate on figuring out what's happening with the spindle motor. Alright, so I hooked up my oscilloscope probe to the plus of the spindle motor, right? So the spindle motor is this one right here. You have the upper pin here and then the lower pin there, right? These are labeled on the schematic as D1 minus and D1 plus. Now I hooked up my oscilloscope, as I said, to the D1 plus labeled lead, which goes in effect to a chip on the controller board for the CD player. Well, for the player itself, so the mechanism. Now, I grant you it's a bit of, it's the lazy way of doing things, but I mean, since the wires are already there, it's just too convenient to ignore, right? So I hooked up the oscilloscope to the D1 plus lead, and I'm observing the trace on my oscilloscope. So as some of you will notice, the oscilloscope is set to 100 millivolts per division, and I'm observing the DC level. Okay, so watch what happens when I open and close the tray of the CD player. There. You see the trace jump up and down a few times. Now I can't help noticing that the trace actually reacts the way the CD laser diode reacts. Yeah, it blinks a few times, 2 or 3 times, and I can't help noticing that the trace is moving up and down at the same rate as the laser diode blinks. But there are no huge changes in voltage. In other words, there seems to be no voltage sent to the spindle motor. I mean, like, absolutely none. Now, one of my viewers suggested that it might not move up and down, it might not launch the spindle motor, let me say it that way, if there is no CD in place. So he suggested in fact that the spindle motor would only start to run if the laser diode actually detects a CD. So let me think a little how I could simulate that in the actual setup. I mean, the CD player is standing on its end, right? So if I put in a CD, how can I observe it running without it falling out? Alright, so I placed the tray horizontally and I unmounted the top cover from the bracket, which is normally mounted on top of the tray, okay, and which is slightly magnetic. So whenever the reader moves the spindle into the disc, it picks up this and clamps the disc with the magnet, alright, because it's slightly magnetic, the spindle. So in that way we could observe, of course, whether the thing would run, would turn or not. Now obviously, since we know the spindle motor isn't running, what we want to observe is whether the motor gets some signaling, you know, to run some sort of signal. And so my oscilloscope is still connected to the spindle motor D1 plus labeled lead or power lead, yeah, and I'm still monitoring the signal which goes to the D1 plus lead. Okay, so let's see what happens when I open and close the CD player tray, right? So watch in the distance the oscilloscope screen. Okay. You can tell there is some sort of signal going to the spindle motor lead, right? It's not a very strong signal. Let's see. I would estimate peak to peak maybe 750 millivolts, yeah, and it's certainly not simple DC. It's a pulsed DC. All right, so I kind of doubt that 750 millivolts would be sufficient to run the spindle motor, though. So I'm sort of thinking in the direction of a faulty chip. The spindle motor is driven via a chip, namely, which I'm going to show you in a minute. So yeah, I think maybe the problem is the chip and not the motor, but I need to have a closer look at the motor first. Oh, okay, I'm going to show you, before I do that, I'm going to show you the signal I get on the screen, right? When I close the CD-ROM or the CD reader, right? So there you go. Okay, I am opening the tray now. Alright, and now I'm closing it. Yeah. That's the signal I'm getting on the D1 plus lead of the spindle motor. Okay, so let me have a closer look at it all, and then I'll follow up with an update. Alright, I'm taking a break from the electronic side of repairing the Technics CD Player, and I'm concentrating more on the aesthetic side of the machine. And one of the things that I would like to solve is the scratches on the display window, you know, or I guess some would call it the display lens, right? And yeah, you could tell it's pretty scratched up. So although if you look at it from the front, it's not too bad. I mean, you could still read the display, but it just doesn't look nice, right? So I'm going to try to polish out most of the scratches, and I'm going to try my lamp doctor polishing compound first. Okay, so I'm not sponsored by the brand or anything. It's just something that I bought a few years ago, and I was pretty happy with it. So I'm going to use it to buff out most of the scratches on the display lens or the display window, and then I'm going to finish cleaning up the buttons. I cleaned them in my ultrasonic cleaner first, but although that took away most of the grime from the buttons, they are still here and there, there's still a bit of dirt clinging to them. So I'm going to give them an individual cleaning with some probably with some degreaser and pure alcohol. And then I will concentrate on the rest of the front bezel. There are a few scratches on the top of it, and a few nicks and scratches along the sides and all that, so which need addressing. More than likely I won't be able to take out most of the scratches, but I mean, as long as it looks respectable and clean, I guess I will have done the best I could with what I have, right? Alright, I used the first coating of K2 Lamp Doctor. Okay. And I'm letting it dry a little, and when it's dry I'll clean it off with a clean rag, and then depending on how scratched it still is, I might give it a second go with polishing compound. Alright, remember how scratched the surface was of the lens of the display? Well, this is how it looks like now. Alright, it's not perfect, but it's certainly an improvement over what it was before, right? So there you go. And by the same token, I also cleaned the front panel. Alright, so it looks reasonable. I mean, certain scratches were just simply too deep to take them out. I mean, I could probably sand them out with some very fine grit sandpaper, but if I do that, the plastic will lose its luster, and it would be damn hard to restore it to its original color and luster. Remember when way back in episode 1, when we measured the voltages on the specifically on the power supply of the CD player, right? And even more specifically, the voltages around Q13, among other voltages. we measured way back then something like minus 13.4 volts, while the schematic specifically says it should be minus 11.2, let's say ranging from between minus 11 to minus 11.2 volts. So clearly the voltage was way too high. And to solve the problem, not only around this transistor, but around all the transistors which are dependent of this part of the power supply, so I modified one thing. I added one thing to the PCB, which is a 1/4 watt resistor in parallel with capacitor C19 here. Okay, so in parallel with this capacitor, I put a resistor of 5.6 kilo ohms and a 1/4 watt. And that seemed to have solved the problem. So now, when we measure the voltages on Q13, let me show you. Oh yeah, it's off. Wait, let me switch it on. Okay, so when it's on, yeah, we measure minus 11.3 at the emitter, and at the collector we measure a little below 12 volts negative, while on the schematic it says it should be, well, somewhere around minus 14.9, 14.6. okay, so it's a bit lower, but the voltage at the emitter, which is really the important thing, is exactly what it needs to be, namely minus 11.2. okay, now making that modification on the print board had as a result, of course, that all the other voltages which are outputted from the power supply to drop a little bit, yeah, and they all dropped well within the voltage ranges that they were supposed to be according to the schematic. So yes, you could say that one modification made a whole world of change, and the change was quite dramatic in a good sense. Now, why am I mentioning this? Well, one of the reasons that I suspect they did it, so you know, the engineers at Technics aren't stupid. Yeah, they more than likely designed the power supply over days, weeks, even months maybe, to work according to the necessary specifications. So in my opinion, what was happening here was something that we call planned obsolescence. So what they actually did was design the power supply in such a way that the voltages that are being outputted are slightly too high. So by, say, 1 volt, a volt and a half, something like that. And you know, if you put too much voltage in components, after a while they start to heat up, and they really start to wear down quicker than they should, you know. So yes, like I said, I suspect that there was, let's say, a very subtle sort of planned obsolescence going on here. Okay, so now you could ask, okay, why wasn't the CD player playing. So in the end, why was the CD player not detecting that there was a CD placed in the tray, and why didn't the CD start to spin to allow the processor of the CD player to detect the number of songs and their duration and all that? So what was happening here? Well, back in episode 1, what I did was I unmounted the CD player mechanism, so this whole thing here, out of the CD player, and I started measuring a few things. Actually, no. What I first did was, on the control board of the CD player, I replaced most, if not all, the caps, okay, just to make sure that I could rule these out as possible problem, let's say problem area, okay. And then I started measuring voltages on the board, and more specifically voltages that are outputted from this chip here, which is a, let me show you, an 8389S from Technics. Okay, let me show you here. Okay. Come on, focus. Focus! There you go. Alright. So I started measuring voltages that were outputted by this IC. Yeah, and more specifically, the voltages which were output towards the spindle motor. So the spindle motor is actually the motor which normally sits here. Okay, so if you have the assembly with the laser diode which reads the CD, the spindle motor sits right here. Okay, and the spindle motor is actually this little thing here. Okay, so I looked it up, and this little motor here is called a Mabuchi RF310T 11400. Alright, so I don't know if you can see, but it's pretty small, but there you go. Okay, Mabuchi RF310T 11400. Okay, so basically the motor has a diameter of 24 millimeter, so almost but not quite 1 inch, and the body of the motor has something like, I think, 18 millimeter height. Okay, and then the shaft stub you see here has something like 8 millimeter or 10 millimeter, I don't remember, height. Alright, and the little motor you see here was attached to the right above the laser diode which does the reading of the CD-ROM or the CD, and it was attached with two little screws, these two little screws, to the body here, and this assembly was actually, all things considered, really simple to disassemble. Let me show you. Alright, so how in the end did I discover that where the problem was located. Why wasn't the CD player detecting a CD when I placed it in the tray, you know? And why wasn't it spinning the CD in any case? Yeah. So I had to dig pretty deep into, let's say, the playing mechanism, the tray as it were itself. And I started obviously by the controller board, which is actually attached at the bottom of the CD player mechanism. Just to be sure, just to rule out that there would be any problems with the capacitors, I replaced most, if not all of them, on the board. Okay, and then I started to methodically measure the voltages given out specifically by this little chip here, which is a Technics 8389S. Let me show you. There. You see? So this chip controls, among other things, the little motor that spins the CD around, which is exactly what the little motor would need to spin, right? So the spindle motor is actually this little thing here. Okay, and this is a Mabuchi RF310T 11400. Let me show you from close up. Come on. There you go. Okay. So this is a Mabuchi RF310T 11400. And I looked it up on the internet, and the specifications for this little motor are that it uses voltages between 1 and 6 volts DC, and at maximum speed it uses about 170 milliamps, at that normal running speed about 60 milliamps. Okay. The diameter of the motor is pretty small, is 24 millimeters, which is just a little bit under 1 inch. Yeah, and the height of the body, if I'm not mistaken, is 18 millimeters. So this height here. Okay. The stub of the shaft is, if I'm not mistaken, 8 millimeter high, or maybe even 10 millimeter, but not much higher than that. Okay. And obviously the screws were used to attach the little motor. Now you might ask, okay, but how did you find out that the problem in the end was the motor and nothing else? Well, by a very simple and expedient method, which was I disconnected the motor wires, so which went to these little tabs here. Okay, so this is a positive marked with red, the other is a negative, and I applied a voltage, a DC voltage, to the motor with my power supply, and I went, I think, all the way up to 3 volts and a half or something like that, and nothing happened. The motor just wouldn't run at all. So clearly the motor was broken. Okay, so you might say, okay, but how did you manage to disassemble it? Well, actually it's not that difficult. So what I started by doing is I released the controller board from the bottom of the CD tray okay, which is done by taking out 3 screws and then disconnecting the connector which goes to the reader assembly, so this little thing here, okay, and you see it has a flat cable here, yeah, and the flat cable fits right into this little contact bus. So you slide this up, you slide it up, and then it just releases the flat cable. And then you pull out the cable for the which supplies the power to the whole board, okay, here. And then finally you disconnect it from the main PCB by pulling this out. So there you go, I disconnected the controller board completely. Obviously after measuring the voltages, you saw that I measured the voltages out being outputted from this little chip here on my oscilloscope, and it was outputting pulsed DC. So to me it was logical almost that the IC was good but the motor wasn't. So again I disconnected the whole controller board, and then I had to remove this assembly here, okay, which has the little laser diode which reads the CD and the spindle motor. So how did I do that? Well, first of all, you need to remove the tray, okay, which is that thing on which you lay the CD. So to remove the actual tray from the CD mechanism, as it were, you actually need to do this. You first need to remove the metal bracket which is mounted at the top here, like this, okay. So you need to remove this bracket first by releasing 2 screws, yeah. Once you've done that, there are 2 little hooks here, 2 little tabs here. There's one here and there's another one here. Let me show you. I'll give you a close-up. So there's one tab here, see, right here, and there's another tab which has more or less the same shape right here, and you can slightly bend it, you know. You don't need to bend it really hard, just a little bit, enough to make the tray, this tray here, slide out completely, okay, because this tray will be kept inside the body by those 2 hooks, those 2 tabs I showed you. Once you remove the tray, it's really simple. The little reader mechanism, yeah, is located right here, yeah, like this, in this white plastic body here, and it's held in place by a clamp here and one very big screw here. So you unscrew that huge screw and you unscrew the clamp and you take it out, and then you're almost there. When you're sure that you disconnected the whole controller board from the bottom of the reader mechanism, you need to release the little rubber feet which hold the reader head in place, okay, and the little rubber feet are right here. You see there are 4 of them. In this CD player, 3 of them are amber colored and one is black colored. It doesn't really matter. In my opinion, the color is totally irrelevant. The only thing you need to do is to push gently those rubber tabs out of their sockets in here. Okay, so there you see those rectangular openings here, 1 and 2, and then there's one here, there is 3, and then there's one here, that's 4. Okay, so you just need to push, oh sorry, no, 1, 2, 3, 4. Okay, you just need to push those little rubber feet out of those openings, and there you go. Well, then you're almost there. So at the top of the reader mechanism, let's say, there's a little spindle, right? And a little spindle looks something like this. Okay, it's magnetic, by the way. The head of it is magnetic because it will attract a cap which will clamp the CD tightly onto the reader head. Okay, so this, yeah, will sit on top like that. Okay, and underneath, of course, there's a little motor attached with 2 little screws like this. So the only thing you need to do is to slide a very small screwdriver. Let me show you something like this. Okay, something like this, and you slide it underneath the cap. Yeah, there are slots in the black plastic, so you slide it underneath the cap and then you lever it up like this, but gently, and the cap will simply pop loose. And once that is done, it's really simple. Then you undo 2 screws which will release the motor, and then you just need, of course, to unsolder it from its power wires here, which is brown and yellow in this case. Okay, and that's it. And then you can simply take out the motor. And the motor, if I'm not mistaken, is attached with that typical star-shaped screw head. So I can hear some of you already shouting at the screen, you know, like, oh, you cheated, and you just bought another CD player mechanism, and you didn't even repair the old one, and blah de blah. And no, I didn't cheat. I just, you know, needed to make some progress. I had ordered the motor, the replacement motor, online, but after a week of waiting and still not receiving the motor, I thought, you know, I just can't wait anymore. I need to find a solution to move on, you know, to show you guys the video of the repair. So what I did was I looked around online and I found second-hand the exact same model of CD player sold as a replacement part on eBay, in fact, and I bought this assembly, only this, as a part, a replacement part, and only, of course, after the supplier could tell me that it was actually working, and this one is working. I'll show you. Alright, so let's try it out with one of my favorite discs from the Talking Heads. Okay, this CD is called, the title is Remain in Light. Yes, the Talking Heads. You should try it once. So let's open it up. Okay. And now let me put the CD into the tray. There are 8 songs, so here we go. You can see the CD spin, and the readout says 8 for a total playtime of 40 minutes and 11 seconds. So this tells us 2 things. One, the spindle works, and by extension the whole CD reader mechanism works, including the reader head, yeah, and yeah, it works. Now, like I said, I'm actually waiting for a replacement motor to repair the original reader, okay, and place it inside the Technics and show it you running with the original one. But obviously I'm not going to sit idle, so what I'm going to do next is I'm going to place everything back in the cabinet, in the case of the CD player, and I'm going to clean it as well as I can, and I'm going to connect it up to an amplifier or an output device, and we're going to test whether it can output sound normally or not. Alright, the CD player, well, the reader mechanism is mounted back in place. Everything has been cleaned up as well as I could, and yeah, before I close up the enclosure again, so before I close up the cabinet of the CD player again, I just wanted to give you a bird's eye view of the interior of it. You know, just to sort of button up the story, so to speak. So there is one thing that I forgot to film for you guys, and that's the adaptation I made for a fuse right down there. Okay, so it's like this. According to the schematic and the service manual, the transformer, which you see over there, is fused. So inside, in the primary, somewhere inside the transformer, they included a fuse. And I honestly, I hate that. That's one of those blasted things that they that you know, large companies did to build in a certain measure of obsolescence into their devices. Obviously they can cover it up by saying, oh, but it's for your protection, it's a safety measure, etc., etc. But what they never tell you is that if the fuse inside the transformer blows, then basically you have to replace the whole transformer. Yeah, which of course is not cheap and a lot harder to do than just to replace a simple fuse, right? So what I did was I unmounted the AC connector, which you see here at the back. I unsoldered it from the main board, and then I bent one of its leads up, to which I soldered a wire, which is this white wire you see here. So this is silicone wire, yeah, and then the other wire that leaves the fuse holder, I soldered them back in place of the original pin of the connector, right? So in effect, the wire, as you can see down there, is bent underneath the connector and then plugged into the main PCB where it is soldered. You might wonder which type of fuse I installed. Since this is a 13 watt device according to the specifications, and since I don't have any smaller fuses, I installed a 35 milliamp fuse in the fuse holder, and that should do. That should be enough. Alright, so yeah, I think that would work perfectly, and in fact we'll see right away when I switch it back on. If the fuse is too light, it'll blow as soon as I switch the CD player on. Either way, I think this is just as safe, and at least if there is some short or over voltage on the AC, the only thing that will blow up is a 10-cent fuse instead of a $15 or $20 transformer, right? So then what did I do? I replaced all the electrolytics on the main board. So every electrolytic capacitor you see is a new one, brand new. Alright, and then I also replaced a few diodes, and to replace those diodes I used a very generic 1N4007 diodes, okay, so like these two over there. Okay, so you might ask, okay, but how did you know which diodes to replace? Well, truth be told, the original diodes were probably good, but yeah, I found when I measured them, their resistance value was a bit out of range compared to similar diodes on the PCB, and also, you know, they just looked funny, a little bit, you could say, burnt or cooked, like some would say. So yeah, I replaced those that looked a little bit funny, and I think I replaced in all 4 of them. So down there I replaced those 2 as well. Okay, so yeah, there you go. I replaced 4 diodes and a whole bunch of electrolytics. Oh, and I almost forgot to mention, and I modified the circuit by placing a 5.6 quarter watt, a 5.6 kilo ohm quarter watt resistor. Yeah, the blue one you see over there. Alright, and you might ask, okay, but wait, you know, that resistor, what in the end, what did it change? Well, it brought the voltages on the main board, so, and on the power supply side of the main board, back to normal. Yeah, so it dropped a little bit the output voltages, and mainly the output voltage which feeds the display. Alright, the VFD display at the front. Now VFD displays are very sensitive to over voltage. So the more voltage you put through them, and obviously current, the more rapid they grow faint, yeah, or eventually they burn out. So I lowered the voltage to what was specified on the schematic, and it is my conviction that that doing that will have prolonged the lifespan of the VFD display, and it's just as bright, as you'll see in a minute. So yeah, there you go, that's what I did. And okay, obviously I cleaned everything as well, inside and out. So what I'm going to do next is I'm going to mount the cover of the CD player, and then I'm going to connect a few speakers to it, and we'll listen to a few fragments of CDs, right? And there you go, a freshly painted matte black case cover, you know. And okay, it's not perfect, but it's certainly an improvement over its initial state. Alright, I connected my little speakers. These are a simple pair of PC speakers, but that'll be enough just to demonstrate the outputs of the CD player, right? And you know, just remember that I can't play complete songs, obviously, for, well, copyright reasons, but I'll try to play a few fragments of certain songs just to demonstrate the abilities, let's say, of the CD player, right? So, okay, here we go. We have power, at least it's standby right now, so let me show you. So when it's standby, the red LED is lighting up. Okay, so okay, here we go. Okay, it says no disc, which is normal, there is no CD in it. So let's lower the CD. Okay, going to load one of my favorites, which is the Michael Nyman, the Draughtsman Contract CD. Okay, so let's see if it recognizes the CD, right? Oh yeah, so it says 7 songs for a total playtime of 40 minutes and 42 seconds. Alright. Okay, so let's see. So these buttons allow you to hop from song to song quickly. So there are 7 songs. Obviously you can go to song 1, 2, 3, etc. all the way to 7, and if you click once more you're back to 1, and you can go backwards too. Alright, so then you have a play button, a pause button, and a stop button. But interestingly, you also have a few other buttons here on the left side. Okay, so there are 2 buttons here that I do not understand. I haven't found out yet what they are supposed to do. So there's a button called time mode, and there's one called peak search. I tried them out, but I can't make tails nor head out of their function. I don't understand what the purpose. I have no idea what the function of these two buttons is, time mode and peak search. So if any of you know what these two buttons do, please let me know below the video, okay? Now, the random and the auto cue button, on the other hand, I do know what their function is. Random is exactly what it says. As soon as you push random, the CD will start to play random songs, the CD player I mean. Auto cue, on the other hand, is interesting in the sense that it allows you to sort of start playing a song, but without actually starting it, as long as you don't push the play button right here. Okay, so if I press auto cue like this, then I press play, you see it goes immediately into pause, and then it will only start to play when I press the play button. Now I know some of you will ask, but what's the use of that function? Well, let's say nowadays maybe it doesn't have that much use anymore, but in the olden days, if you wanted to transfer music from a CD to another CD player recorder, because don't forget, this doesn't record music CDs, okay? It just plays them. So if you wanted to transfer the songs from one CD player to another CD player recorder, then you could pause the song and then start the recording at exact the same moment you start to play the song. So that's what auto cue is, okay? Obviously nowadays the function of auto cue is, well, useless largely, but there you go, that's what it does. Okay, so let's see if it plays. Yes, it does. Let's hop a little bit further into the song, like here. So this is dual use button, okay? If you just want to move further on in the song, you press the button and you keep it pressed. If you want to hop to the next song, you just give it a quick press, okay? Alright, let's go to, I don't know, song 3. Okay, let's go to song 6. Yeah, so I would say this CD player works great, right? So there you go. Unfortunately, I can't play. Let's see. Maybe I could let you hear another CD. which is also one of my favorites. You know, like I told you before, Talking Heads is one of my favorite groups. Okay, so let's load this CD and see what this does. There you go. Okay, 8 songs for a total playtime of 40 minutes 11 seconds. Let's go, yeah, to song 1. Okay, let's hop. Okay. Let's go to song 2. Okay, song 4. I'm sure some of you will know this song. In fact, I'm 100% sure most of you will know this song.
In another part of the world, and you may find yourself behind the wheel of a large automobile. Same as it ever was. Same as it ever was. What of the zombie? And what of the movie?
Yeah. So, there you go. We'll end with this song from the Talking Heads. So the final conclusion is we did manage to repair this sorry looking CD player when I first got it into, well, you could say from an ugly duckling to a beautiful swan, right? So obviously if you look close at it, yeah, from up close you will see a few traces of its past life, but in the main it looks great actually, and it works beautifully. So I would say yet again another CD player saved from the scrap heap. So there you go, the repair and the refurbishing of a Technics SL-PG480A CD player. Thanks for watching, and I'll see you soon for another video.